Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1 Foundation Tier from 2021. This is a full paper walkthrough. I will be going through questions 1 to 5, but this paper has 7 questions. Questions 6 and 7 are higher tier questions, meaning that they appear in the higher tier paper as question 1 and question 2. So I will do those 2 questions as separate videos and link it to the playlist for this paper. This paper is out of 70 marks. Question number 1 is on the topic of atomic structure and the periodic table. Magnesium is in group 2 of the periodic table. 1 gram of magnesium reacted with chlorine to produce magnesium chloride. What type of elements react with magnesium? React when magnesium reacted with chlorine. Magnesium is a metal and chlorine is a non-metal. It's a reaction between a metal and a non-metal. Write the word equation for the reaction when magnesium reacts with chlorine. So they've already given us the answer. So magnesium plus chlorine gives you magnesium chloride. Remember, it's chloride, not chlorine. When apparatus was used to, what apparatus was used to measure the mass of 1 gram of magnesium? That would be a balance. What mass of magnesium chloride was produced? Well, if you remember from the start, they are using 1 gram of magnesium. So 1 gram of magnesium is reacting with chlorine, which will add to the mass of magnesium when it reacts. So the mass should be more than 1 gram. This is linked to the law of conservation of mass. Magnesium reacts with oxygen to produce magnesium oxide. Calculate the percentage mass of magnesium in magnesium oxide. So they have given us the magnesium mass is 24 and magnesium oxide is 40. So all I have to divide is 24 divided by 40 multiplied by 100. That gives me 60%. Magnesium carbonate decomposes. Decomposes means to break down. To produce magnesium oxide and carbon dioxide. The word equation for the reaction is magnesium carbonate, gives you magnesium oxide plus carbon dioxide. 4 students heated 2 grams of magnesium carbonate for 10 minutes. Table 1 shows the results. So you have 0.97, 0.91, 0.5. This looks like it's an error because it should be very close to 0.9. So, and then 0.95 X. Okay, what is the most likely reason for student 3's anonymous result? The student heated more than 2 grams of magnesium, could be, but the student heated the magnesium carbonate for less than 10 minutes is most likely. And the last question, calculate value X. Do not use the anomalous result. So they are already telling us not to use it. And you need to give your answer in 2 significant figures. So let's add the values up. 0.97 plus 0.91 plus 0.94. Add them up and then divided by 3 will give you 0.9433 recurring. So in 2 decimal place, it will be 0. Significant figures, it will be 0.94 grams. This question is about electrolysis. Question number 2 is on the topic of chemical changes. So this question is about electrolysis. Complete the sentence. Copper chloride can conduct electricity when in solution or when molten. Molten is when you heat it so that it actually melts. Figure 1 shows the apparatus used for the electrolysis of copper chloride solution. So you have a beaker with copper chloride solution, positive and negative electrode connected to a power supply. There are 4 ions in copper chloride solution. So you have Cu plus, 2 plus, Cl minus, H plus, and OH minus. Why do Cl minus and OH minus ions move to the positive electrode? Well, because opposite charges attract. Okay. Where do the H plus and OH minus ions come from in the electrolysis of copper chloride solution? That would be from the water. Which ion produces a metal? That would be the copper ion. Figure 2 shows the apparatus during electrolysis of copper chloride solution. Describe what is seen at each electrode during the electrolysis of copper chloride solution. Now, as you can see from the diagram, it looks like there's bubbles of gas being given out at the positive electrode. So remember, they've already told us the ions that are present is Cu2 plus, H plus, OH minus, and Cl minus. Now it's these 2 ions that are going to be reacting at the positive and negative electrode. So at the positive electrode, chlorine is formed, but what they're asking is what is seen. So you can also see the bubbles. So that's all you need, right? Bubbles are produced. You don't even have to say what it's actually made up of, but we are going to say chlorine gas. At the negative electrode, it looks like something's attached to it, which is going to be the copper, right? So what will we see? We will see an orange solid is formed, which is the copper. You could say it's deposited as well. 500 centimeter cube of copper chloride solution contains 6.5 grams of copper chloride. Calculate the mass of copper chloride in 40 centimeter cube. So if I divide 6.5 grams by 500, I'll find out how many grams is in 1 centimeter cube. Then I can multiply that by 40 to find the mass in 40 centimeter cube. That will give me 0.52 grams. 0.52. Question number 3 is on the topic of atomic structure and the periodic table. Carbon can exist in a number of different structures. What is the approximate radius of the carbon atom? It has to be in nanometers. It doesn't matter what number it is. So it's the third one. Figure 3 shows a carbon atom. So it's a 6-mark question. Surprisingly, after a long time, I'm seeing the 6-mark question here in the right one early. Anyway, okay, so that's the electrons. There's 6 of them. These are the shells. The positive is the proton. How many are there? There's 6 of them. These are the neutrons. And there's 8 of them. No. Oh, Usually carbon will have only, usually carbon does have only 6, which I actually wrote down, but here it has 8. That's because carbon also has isotopes. So, question, describe the atomic structure of this carbon atom. You should include the number of electrons, neutrons, and protons. So by doing this, I've already probably got about 3 marks already. Protons and neutrons make up the nucleus. So that's more or less what we need to write. So there are 6 protons and 8 neutrons in the nucleus of the carbon atom. There are 6 electrons in the shells, right? You don't have to say how many in each shell, but if you want to, it will be 2 and then 4 electrons, right? And that actually, according to the marking scheme, saying 6 protons, gives you 1 mark. Saying 8 neutrons gives you another mark. Saying 6 electrons give you the 3rd mark. And mentioning that protons and neutrons are in the nucleus, that gives you another mark. That's 4 marks. Actually, mentioning that both protons in the nucleus and neutrons in the nucleus gives you 2 marks. And that the electrons are in shells gives you the 6th mark. In 2 sentences, you can get the 6 marks for this question. In graphite, the carbon atom are held together by bonds. Figure 4 represents part of the structure of graphite. So you have the layer of carbon atoms. How many bonds does each carbon atom have? In graphite, that will be 3. What type of bonds hold the carbon atoms together in graphite? That is covalent, because covalent is between nonmetals. Lubricants allow objects to slide over each other easily. Suggest why graphite can be used as a lubricant, since the layers can slide over easily. The 2 structures represent different forms of carbon. Draw one line from each structure to the form of carbon. So the first one is diamond, and the second one is Buckminster fullerene. Sodium and potassium are group 1 elements. What is the name of group 1 elements? That will be alkali metals. Halogens are group 7. Noble gases are group 8. Figure 5 represents the melting point of group 1 elements. So you have group 1 elements, lithium, sodium, potassium, rubidium, and cesium. What is the melting point of sodium? That's slightly below 40. Would you write it as 40? No, so sorry, sodium. I was looking at rubidium. So sodium is below 100, so you could say it is 99. We say it's 99. Yeah, it is 99, but they will accept answers anything between 97 to 99. 9. Sodium reacts with water to produce sodium hydroxide and hydrogen. Balance the equation for the reaction. So we need to just balance the sodium. There's 2 sodium here. So there is 2 there. Calculate the relative formula mass of sodium hydroxide. So sodium is hydroxide NaOH. So all we need to do is add it up. 23 plus 16 plus 1. That gives you 40. Sodium and potassium both react with water. Compare. Figure 6 shows sodium reacting with water. Compare what is seen. So again, they're asking, make sure that you highlight that seen. What would you see when sodium reacts with water and potassium reacts with water? So in both reactions, we'll split it up. In both reactions, the metals float and move about. I'm combining points, so this is actually 2 different points. They melt, giving out a gas. Free. They form a ball and get smaller, eventually disappearing as they dissolve. Now, the difference is in potassium, it moves faster, bubbles faster, reacts faster, dissolves faster, and catches fire producing a lilac flame, meaning a purple color flame. A student investigated the change in temperature when different masses of zinc were added to copper sulfate solution. This is the method used. Measure the volume of copper sulfate solution using a measuring cylinder. Pour the copper sulfate solution into a metal container. Add 2 grams of zinc. Measure the temperature of the solution. Repeat steps 1 to 4 with different masses of zinc. You have the metal container, zinc, copper sulfate solution, thermometer. Give 3 improvements to the investigation to make the results more accurate. Now, instead of a metal container, use a plastic or polystyrene container or cup so that you don't lose a lot of heat. You could say add a lid. You could also say stir the mixture. These three will give you the 3 marks, but I can write 2 more. Use a digital thermometer and use the same volume of copper sulfate solution. Figure 8 shows part of the measuring cylinder. What is the volume of copper sulfate solution in figure 8? So that's 10 divisions between 70 and 80. It's in the second division, so that's 72. When zinc was added to copper sulfate solution, the temperature increased. That means it's an exothermic reaction. Figure 8 shows the reaction profile. These are the reactants. And these are the product. What type of reaction is shown? It's an not an endothermic, it's an exothermic reaction because energy is being given out. Figure 10 shows the results. So temperature change, it went from 0 to 50, and they marked increase in mass and increase in temperature. Determine the gradient of the line in figure 10. Gradient equals increase in temperature divided by the increase in mass. Increase in temperature is 50 degrees. Increase in mass is 6 grams. Gone from 0 to 6. So 50 divided by 6 will give you 8.33. Suggest why the student should not use more than 10 grams of zinc. Use figure 10. Well, if they used more than 10, it's actually a straight line. So if you continue doing this, there you go. If it's 10 degrees, 10 grams, the temperature is going to be really hot till about 80 degrees, and that could be a risk. So you should extend the graph line as I did. So they are saying you to extend. So you should draw over the line up to 10 grams. So the temperature would increase to 84 degrees Celsius, right? So the solution will be too hot. You could say boil, although it's only at 84. This question is about the periodic table. Figure 11 shows part of the Mendeleev's version of the periodic table. So if this is Mendeleev's periodic table, which group of elements had not been discovered when Mendeleev's version of the periodic table was published, that would be group 0. For the noble gases, figure 12 represents different models of the atom. So first one is what we call the planetary model. This is the plum pudding model. These are the ones that you need to know. Not plum pudding model. This is solid sphere. Which model represents the plum pudding model? That will be B. Which model resulted from Chadwick's experimental work? Chadwick was responsible for saying that the electrons are in shells, so that will be A. Potassium has different isotopes. What is meant by an isotope? We should refer to the subatomic particles, right? Atoms, isotopes are atoms with the same number of protons but with different number of neutrons. Table 2 shows the mass, numbers, and the percentage abundance of two isotopes of potassium. We got mass number 39, 93.1, 41, 6.1. Calculate the relative atomic mass of potassium. Give your answer to one decimal place. So to do this, you need to just multiply the mass number, which is 39, multiplied by the percentage, 93.1. Add that to the mass times the percentage. And if they have give you 3 or 4, it doesn't matter. You just do the same thing, and then you divide all of them by 100. That should give you 39.138. So in one decimal place, it will be 39.1. I've done question 6 as well. Okay. I believe I've done question 6. So I've done question 6 as well in this video. Question 7 will be linked as a separate video to the end of this video. I meant to do only question 5, but I just got carried away because I enjoyed answering this paper. Thanks for watching. Hopefully you find it useful and you enjoy answering questions in the exam paper. If you enjoy it, you will find it easy. Thanks for watching. I will see you in the next video. Bye for now.